All right, so part two of this lesson is going to be about line reflection. So you've all been exposed to this before, nothing crazy, but you want to make sure that you understand what you're doing here. So a line reflection, once again, remember, was a flip. All right, you're flipping over some type of line. All right, so the three biggest here are a reflection over the x-axis, reflection over the y-axis, and then we'll get to the rest in a minute. All right, lowercase r for reflection, subscripted line over which you're reflecting. All right, so if I'm flipping over the x-axis, that would be what's subscripted, lowercase r precedes it. All right, so if you were looking here, and we draw in our x and y axes, all right, y-axis, x-axis, and I picked a point, and it happens to be my favorite point, point P, 5, comma 1. All right, so if we were flipping over the x-axis, all right, all you do, and I want you to imagine that we have like the graph grid here, right, the coordinate plane. All you're doing is counting the number of spaces, the number of boxes, until you reach that line over which you're reflecting. So in this case, 5, comma 1, right? Think about how you plot the point. 1, 2, 3, 4, 5, up 1. So how many spaces is it from the x-axis? Just 1. So you'd be counting down to the axis and then repeat on the other side. So this is like a count and repeat situation. All right? So think about this. 5 up 1, but now this is 5 down 1. This point, your image, P prime, is going to be 5, comma what? Instead of up 1, down 1, negative 1. All right? Now, you can do that with any point you want, right? If I had done 0, comma 3, right? Let's say that was point Q, right? 1, 2, 3, 1, 2, 3. So now your Q prime, you'd be down there. Well, if this was 0, 3, this is 0, negative 3. 5, 1, 5, negative 1. All you're doing is changing the sign of the y-coordinate. So with the reflection of the x-axis, your xy turns into, if I flip over the x-axis, your y-coordinate changed sign. Your 0, 3 became 0, negative 3. Now, if it was negative to start, it would have went positive. So your x turns into negative x. So it switches the sign of the y. All right? So your x stays x, your y turns to negative y. All right. Same exact concept, but reversed with your flip over the y-axis. All right? I'm going to stick with my point here. 5, comma 1. So if I was reflecting over the line, which is the y-axis, all right, you would count to that axis. 1, 2, 3, 4, 5. So you go 1, 2, 3, 4, 5 to get there. And you repeat 1, 2, 3, 4, 5. So if this is 5 up 1, it's still up 1, but now you're 5 on the other side. Your point P here would be negative 5, comma 1. All right? Same thing. If I was over here on the negative side, I would count 1, 2, 3, 1, 2, 3, and it would turn positive. So your XY, your rule for your flip over the y-axis, your xy, is going to map onto, well, the 5 turned to negative 5. So the x changed the sign this time. So negative x, and then your 1 stayed 1. So your y stayed the same. So when reflecting over the line, over the y-axis, your xy maps onto negative xy. And when you reflect over the x-axis, your xy maps onto x negative y. So your x, 5, 5 stayed the same, 0, 0 stayed the same, but your y's switched coordinate sign. All right, so that's that. Those are the two most basic. Kind of a review in middle school there also, but still part of the high school curriculum. Now, this guy is important, and something you'll use in your future math careers here. All right, you got your xy, same concept, but your line y equals x, which, granted, if you had a graphing calculator in front of you, wouldn't be that hard for you to figure out. All right? But the line y equals x contains all those points where x and y are the same. 0, 0, 1, 1, 2, 2, 8, 8, negative 4, negative 4. It is what's referred to by many math teachers as your perfect diagonal. All right? Your perfect diagonal. So, oops, sorry, hit the camera. So if you're flipping over this line, right? There's something kind of tricky that happens, but it's super easy as long as you know the rule. Like wildly easy as long as you know the rule. So I'm back to my point, 5 comma 1. All right. Look, imagine the point was here. It would just be right there. You go right to the point, right to the line, and then right out. Perpendicular in, perpendicular out. Here, there. Here, there. So look at it. This is your first quadrant right here. Remember your quadrants? 1, 2, 3, 4. If you're in the first quadrant and you flip over this line, you're going to stay in the first quadrant. If you're in the third quadrant and you flip over the line y equals x, you're going to stay in the third quadrant. 4 would go to 2, 2 would go to 4. So if I'm in the first quadrant here with my positive 5, positive 1, which of course I am, I'm going to stay in it. So now look, if I went right at it and right up, this is going to be my point right here. This is going to be my P prime. Now look at that. It's kind of close to this axis, up 1. Now it's close to this axis, over 1. If this is 5, 1, this is, any idea? 1, 5. All right, so what happened? 5, 1 became 1, 5. All right, well, what if it was here? What if it was this point, Q, and that's, 0, negative 4? Well, that will go right there and then right there. So my 0, negative 4, well, now it's negative 4, 0. But all they're doing is switching. That's it. So the rule for flipping over the line y equals x, which is important when you learn inverse and some other things in math in your future, all right, it's going to take your original point xy, you flip over the line y equals x, xy becomes yx. It doesn't get any easier, guys. All you have to do is switch the order of the coordinates. But the hardest part of it is remembering the rule. All right, so that's kind of a big deal. Now, if I'm pushing your level a little bit here, you can really reflect over any line. Now, for high school, all you worry about is, this is really the only diagonal line. Sometimes you do the line y equals negative x as well. But really, you're going to focus on any vertical line or horizontal line. So, okay, you got your x and y axis. Ooh, ugly x. You got your x and y axes there. You may or may not remember what the line x equals 4 looks like. Well, the line x equals 4 is a vertical line that goes through the x-axis at 4. So if this is x equals 4, all right, and I go to any point, I'll change it up this time. I won't use my 5, comma 1. Let's say it was 2, 3. All right. That's 1, 3, sorry. All right, let's say it was 1, comma 3. You would count 1, 2, 3 to the line, 1, 2, 3 to the other side. All right, and then from there, you would just count off on your coordinate plane what point that is. So no matter where you are, all right, you're over here, and it's 1, 2, 3, 4, 5, 6, 7. All right, 1, 2, 3, 4, 5, somewhere over here on my countertop. Right? All you got to do is count directly to the line and then directly across. All right, maybe it's a horizontal line. Maybe it's this line right here, which looks like y equals negative 2. All right, goes through the y-axis at negative 2. Same thing, you would count 1, 2, 3, 4, 5 to the line, 1, 2, 3, 4, 5 to the other side of the line, and read off that point. You would just count it off. All right, so just something else that could come up. All right, but that, in a nutshell, is line reflections and translations. With one last thing I want to comment on for line reflections, all right, they also are always rigid motions. All right? Again, the pre-image is congruent to the image. All right? Hope that all made sense. This will be probably 1 or 2 or 3, I don't know, whatever. A few of these on your Castle assignment for Wednesday, and that's that. We got a live check-in tomorrow, 9:30 on Tuesday, so make sure you're there for that. Big part of your grade, so get in on that. All right, I hope you guys are off to a good start to your week. Talk to you soon. Bye.